DC term or the average term A naught, and sum of two terms, cosine terms and sine terms. Are you fine? Are you right?
Yeah.
Okay. Oh, there is a hole in the chair. What? So an AK is the coefficient of cosine term, and BK is the coefficient of sine term. And how to find AK and BK or A naught? So you have to integrate. All right. A naught is not written in this formula by mistake, but it's just a very simple one that will be like the average, which 1t over, I'm going to add it, 1 over t, the integration of the signal by itself without multiplying it. Well, then we got to know the special cases because it will make it easy and simple. So what does it mean? You have to look for the function. Is it even? It's odd. So you don't have to, like last time when we did the calculation and found that AK is equal 0, took us like long time, 15 minutes at least. So don't do that if it's, but the aim was just to explain how we get it. So I have this table. It shows to you the general case. If it's not even nor odd, you follow this, and you have A naught, AK, BK, how you get it. And then if it's even, so you don't have to get BK. It means you do not have sine terms. So when it's even, you will have cosine terms. It makes sense because cosine is even. So you have cosine term. And another thing, when you make the integration, for example, A naught, you make integration for the whole period from 0 to t. When it's even, no, you don't do that. You do the integration over half period and you multiply by 2. So that's 1 over t will be multiplied by 2. Instead of from 0 to t, from 0 to t over 2. You look for AK, the same thing. 2 over t will be 4, you double it. And instead of integrating over one complete period, no, only a half period. That's if it even odd. And if it's odd, so you don't have A's, zeros. And then you are going to have sine terms only. So only you calculate BK. The same thing. You are going to double the integration and integrate over half the period. That will make life easy. Okay. There are more symmetry, but I don't want to get involved, very involved. Just I'm trying to get just the simple thing that you, because it's the first course, signal processing. There are others, of course, but that's, I mean, that's the basics, by the way. That's the basics. Don't think that I'm exaggerating or giving more than it's supposed to. Then there is something interesting that I'm going to show you today, and you are going to do it in the lab. This formula, it has like cosine plus sine. As you know from trig, you can simplify something like that to one term. Would be like cosine something plus theta, or cosine something minus theta. We call it compact trigonometric Fourier series. And I give it to you here. That's the compact. And instead of having two terms, AK and BK, but C naught is the same as E naught, the average. Doesn't change. That's why I say C naught is equal E naught as the normal trigonometric Fourier series. But for compact trigonometric series, CK, it will be the square root of the sum of the squares of both coefficients, AK squared plus BK squared. You square root, and I'm going to show you the example how you get it. And theta, of course, I mean, here the price will be like one term, that's right, but there is shift. Cosine K omega naught T plus theta K. Here, you don't have the shift, but you have cosine and you have sine. All right, that's, I mean, the difference. It's equivalent. And that's how we find theta K. So that's, I mean, trigonometric Fourier series. We are going to have today, I hope that we'll have time. So how can we get the other thing that's called exponential Fourier series? And instead of using the term sine and cosine, we're going to use the term e power j. And we explain in the complex number what does mean e power j. E power j means cosine theta plus j sine theta. So they return back sine and cosine to the exponential expression, or in other words, Euler form, used Euler form. So we're going to apply this. Which one is good? Both are good, but the last one, the exponential, that will be like, I mean, extension to what we're going to study later, something called Fourier analysis. All right, it will help us in that. That's number one. Number two, this exponential Fourier series is really good and simple and applicable for line spectra or Fourier spectra. What does it mean, Fourier spectra? As I said in the end of the lecture last time, we need something easy, something simple that you can tell me what is the amplitude of each harmonic. The amplitude of the fundamental, DC, the third, the fifth, the sixth, what the amplitude. So we make like lines, we draw lines at each frequency to show you the height. That's called line spectrum. When you plot the amplitude of Fourier series, the result with the frequency, we call it line spectrum. And when you plot the angle shift, which will be like theta k or the angle that e power j theta, that's the theta, the angle. So if you plot the angle against the frequency, we call it, that's the phase angle spectrum. So you have line spectrum and phase angle spectrum, amplitude with frequency, angle with frequency, and both they are called line spectra, both of them. So that's what today I'm not going to explain theory. I just give you simple or summary what we're supposed to do, and I'm just going for example. I'm just go numerical example, and I'll take it step by step. And I'm going to upload another 2 examples. I did it last night. I have it, but I upload it after we do the lecture today, so you understand how you do it. And when you do the lab, apply everything you learn in the pre-lab task. Then you will be fine. All what you need, just do practice for one good problem, and then after that you can do, of course, different problems, even and odd, so you get familiar with that. So let's just pick any signal that we are going to. Last time we did like symmetric. It was symmetric about the. You have the so I want to get different. Oh, it was even. Let me pick it off. So let's sketch. Okay. We'll say that I will take the amplitude different this time. I will not take it 1. I will take like the amplitude is equal 4. And also the period, I will not take it 1 and 2. I'll take it different. So you get familiar with anything. 2 pi, and then start again. The example that is going to be in the folio, it will be more involved, but I don't want to just in the lecture show you, a complicated thing. So you can do, you can work it out. You have the solution, everything. I have like one exponential function, but if I do it in the lecture, I'm going to be explaining integration of exponential with the sign. I don't want to get the lecture, far from the objective. So that'd be minus 5 minus 2 pi. So that's a function or a signal x of t with t, and we need to express this in Fourier series and find line spectrum and find everything. Yes.
I thought it was odd if that left hand side is going to be flipped over the x axis, the t axis.
It's different. I'm just making. I don't want to make even one. I want to make it something different. Yeah. Huh? No, it's not odd. Because if odd be like, be reflected other direction. Well, that has average value. But what we'll do, first we'll find the period. What the steps we did last time, the same thing, and follow me this time. The period t, let me just write, that's the period of the function t is equal to 2 pi, right? Usually the period in seconds, but just I want to get familiar, it can be anything. It's okay to have it like that because pi is a number. So that's the period. Then what we get next? No. Yes, angular fundamental frequency. Yes. Fundamental frequency, which is omega naught, which is equal to 2 pi over t. 2 pi over t, and t is equal to 2 pi, so is equal 1 radian per second. So you got some, just to make sure you write it there, t is equal to 2 pi and omega naught is equal 1, because they are going to use in all the equation. Now, we'll start to get the coefficients one by one. The first one, the average value. And if you're doing that in the exam and simple, you can do it in a fast way. What do I mean by this? Let me find A naught in a fast way using graphical method. The idea of finding the average value is to find the area, spread it over the period. So the area is equal 4 times pi. And the period is equal to pi. So it will be equal to. I didn't do integration. All right. There is equal to. You get the area of the whole thing over the one period and then divide it by the period. Well, now I will apply the formula so you get familiar. A naught is equal to 1 over t, the integration over the period, x of t dt, equal. The period is equal to pi. So 1 over 2 pi, the integration from 0 to 2 pi, x of t dt. According to that, it's 0 from pi to 2 pi. So I'll make the integration. I'll say 1 over 2 pi, and the integration will be from 0 to pi. X of t is equal 4 in this, right? 4, yes. And dt, so that will be equal 4 over 2 pi, and the integration of the constant one will be equal t, and I will substitute between pi and 0. So you have 4 over 2 pi, 4 over 2 pi, and t will be pi minus 0. So you'll have 4 pi over 2 pi, which is equal to the same thing. Of course, it took a long time. You don't do that except if you have some kind of, if you have straight line, triangle, square, just do the area. Doesn't take time. If you have exponential, do the integration. That's all. Now, we're done with A naught. Then we'll find the first term, AK. And you don't have to memorize. It's just everything in this sheet. Everything you need in this one sheet for the whole Fourier. So you will have, it's equal to, according to the formula, AK is equal to over t, the integration over the one period, x of t multiplied by cosine k omega naught t integration with respect to time, b dt. Now let's start substitute by the values. Equal 2 over t is equal to pi. The integration from 0 to 2 pi, x of t and cosine k omega naught is equal 1. So I put just 1 dt. Now I start to look for it 1 over pi, 2 over 2 pi, 1 over pi. And it's only from 0 to pi, because from pi to 2 pi is equal 0. And it's equal to 4 cosine k t dt equal. I'll get the 4 constant outside. The integration will be 4 over pi. The integration of cosine k t dt. What's the integration of cosine kt? It's sine. Negative or positive? Positive. How do I remember that? When you differentiate cosine, what you get? Negative sign, flip the sign. That's it. All right. So now you have 4 over pi, the integration of cosine sine kt over k. That's the integration of cosine kt. And the limit from pi to 0. K is constant, not function of time. I'll get it outside with pi, so you have 4 over pi k. Then you substitute, you have sine k pi minus sine 0. Yeah, any question? Go back. Oh. Oh. Well, good. Now, equal to 4 over pi k. Now you be careful. Sine k pi would be sine pi, 2 pi, 3 pi. Any sign of multiple pi equals 0. So this term is equal 0. All right. Sine 0 is equal 0. So it's equal 0. Sine pi, what's sine pi? Sine 180, 0. 2 pi, 360, 0. So that's any sine pi multiplied by integer equals 0. Pi over 2, there is, a story about. So now we have 0. So it's equal 0. So just to make sure that we got AK is equal 0. So obviously it's going to be like sine terms only. Now I'll go for BK. The formula for BK is equal to 2 over t, the integration over 1 period, x of t multiplied by sine k omega naught t dt. Start substitute by the values of the signal we have our hand. So you have 2 over the t is equal to 2 pi, integration from 0 to 2 pi, x of t, sine k omega naught is equal 1 dkt dt. That will be equal to 1 over pi, and from 0 to pi, and the value is equal for sine kt dt equal. I take the 4 outside, so 4 over pi, and the integration of sine is equal negative cosine kt divided by k, and the limit of integration from 0 to pi. Now the value is equal 4 over pi. Let me take the negative outside, so we'll have negative 4. So it's equal to negative 4 over k pi. K is a constant, also not function of time. So I have cosine k pi minus cosine 0. What is the answer here? Negative 4 over k pi. Cosine k pi, there is a story about it. So let's just look at it. Cosine k pi, when k is equal 1, we get cosine pi. Cosine pi is equal to negative 1. When you have k equal 2, cosine 2 pi is equal 1. If you make it 3, it will be 3 pi negative 1 again. So obviously it's negative 1 when it's odd k, and positive 1 when it's even. So I can write like that, negative 1 power k, because negative 1 power 1 is equal negative 1. Negative 1 squared is equal positive 1. So I can write cosine k pi equal negative 1 power k. I'm going to collect for you the all things like cosine k pi over 2, something like that, and I put it on a sheet. So you just have to look at it and just use it. So now I can write BK equal to negative 4 over k pi. That's I'm writing from here. Cosine k pi I found negative 1 per k, and minus cosine 0 is equal 1. Well, I'd like to reduce it more. Let's multiply the negative inside. So you got 4 over pi k, 1 minus 1k. Surely there's a value. Let me go back and see what's happened. When k is equal 1, what this value of the whole bracket here? When k equal 1, 1 is constant. That's 1 is the same. Minus, and minus 1, bar 1 be minus 1 or negative 1. So that will be 2, right? And if k is equal to 1 is still the same, and minus times minus be plus, be 0. All right. So now I have something else. It's equal to when it's odd, and 0 when it's even. So simply, I'm going to replace the whole bracket by 2. So the answer now, the final answer will be bk is equal 4 over pi over k times 2, and I'll write 4 k equal 135. So simply, I will write just bk is equal 2 times 4 is equal 8 over pi k, and I would say k is equal odd. And just remember that. You will finish with the coefficients, which is really important. If you go to the folio, you will see I have MATLAB written for you how to find the coefficients. That's really very helpful, because when you solve a problem, you can use the program to check if you got the right answer or not. Even you can do the integration. And very important to know that there are two commands in MATLAB: int, int, and integral. Int is for symbolic integration. Integral for numerical value. You will see that in the. Now, how I write the, yes.
Can you explain again why we put 2 with 2 over 4 over 5k?
Why I write 2 here? This is the value of 1 minus negative 1 power k. I just found it here. When I substitute by k equal 1, I found it's equal 2, because when you have k equal 1, negative 1 will be still negative 1. And negative 1 multiplied by negative will be positive 1, and 1 be 2. And when you have it even, k is even like 2, negative 1 square will be positive 1. So you have 1 minus 1 be 0. Yes.
It was all I could do to keep up writing with how fast you were going.
Why don't try it? Why write? I'm going to upload it.
I'd be so screwed in the quiz.
What? No. I mean, no. You know why screwing the quiz? Because you don't pay attention, right? You spend all your brain, right? I said I'm going to upload it. You choose that.
Yeah, but then you said we use our notes on the quiz.
No, use your notes. No. Oh, you mean the quiz?
Yeah.
What? I mean, I mean, if the quiz wants the formula, ask me and I'll write the formula. I don't care.
So why is there a k in the exponent?
Why there is a k next to 1? I'm trying to find equivalent expression for. I mean, when you find something is equal negative 1 or positive 1, negative 1, positive 1, negative 1 when it's odd, positive 1 when it's even. So how you express it? You know that negative 1 when it's raised to odd power, it's negative 1.
Yes.
And negative 1 you square it or bar 4 be positive 1. So I said, okay, I'm going to replace it by negative 1. If it bother you, don't put negative 1 plus k, just put the values.
Okay.
Say that cosine, you can write cosine k pi is equal negative 1 when k is odd, and equal 0, equal positive 1 when it's even.
Like we did 2 days ago.
Yeah, you can do the same thing. I'm just showing something else. So when you see it, you don't just,
And
see, I didn't
this
have
is
it.
shorter hand to do that.
Shorter hand, yeah. It's just another expression. Because I mean, when you read the textbook, you'll find sometimes they are using that. So if I didn't say it now and you look at it and say, what is that? Be a puzzle. So, but you're free to choose whatever. The important part, you get the right answer in the end, right? Right? Agree? Now, how can you write the expression for Fourier series now? You have everything, all right? The formula said that x of t is equal a naught plus the sum from t equal 1 to infinity, an cosine. I'm sorry, I wrote n, it should be k. Because sometimes you can write n, by the way. That's okay. ak cosine k omega naught t plus bk sine k omega naught t. All right. So now we found out that ak is equal 0. Good. So I'll just say that's equal 0. Now I'm going to write the equivalent. A naught we found is equal 2 plus the summation from k equal 1 to infinity. bk, we just found bk. Oh, by the way, we found bk is equal to 8. We have it here. 8 over pi k when k is odd. So I make it here odd. Remember, I don't use 2. I use 3 and things like that. And sine k and omega naught is equal 1. That's it. That's x of t. Let's just expand it to see what we're going to get. So you can write x of t is equal to plus, you put k equal 1. So you have 8 over pi sine t plus, use 3 now. You don't have 2. 3 will be equal to 8 over pi 3 pi sine 3t plus 8 over 5 pi sine 5t, and you can continue to infinity. But as we explained before, that every time you are increasing the frequency, the amplitude is decreasing. So some of the questions come in the exam when I give you something like that. I said, wait, give me the amplitude of the third harmonic. I'm not asking you to write the whole terms because there is no time. I ask you just give me the amplitude of the third harmonic. So if you did right, you'll say the amplitude is equal 8 over 3 pi. There's something I want to tell you about the exam, because I mean, when I ask round your answers to do decimal, 3 decimal, I found some students when I reviewed, I mean, they got low grades. So I reviewed the exam. I found that they have the right answer, but just didn't follow the instruction. Like I asked for 2 decimal or something, and they write the whole thing. So the computer corrects the exam. So he has the answer to 2 decimal. So when you look at even you are right and you have 3 decimal, it will mark it wrong. So please. So now that's, if I ask about it, that's it. That's, you said 8 over 3 pi. Yes. Okay. Now, yes.
You put 3 and 5 because we're only considering the odd, right?
Only the odd. Why I'm doing the odd? Because I found that this one only when it's odd. It's 0 and it's even. Now I want to do using that what I got in determining the coefficients of compact trigonometric Fourier series. In the sheet that you have it in the folio, I will write the formula and I'll tell you. That's the complex Fourier series. We write like that: x of t equal c naught plus ck, k from 1 to 0, and its cosine k omega naught t plus theta k. That's the formula for the compact. It's still trigonometric, but compact. You don't have 2 terms, 1 term. Now, my job to find this expression, I should find what c naught, ck, theta k. C naught, it's equal to E naught. And E naught in this example is equal to 2. That's E naught. E naught. So it's equal to. So that's simple. Let me now find ck. Ck is equal an square plus bn square square root. Well, lucky in this problem because I mean we have only bk, ak is equal 0, right? So since this one is equal 0, so you got actually it's equal to bn in the end, right? So ck is equal bn, which is equal to 8 over pi k. Theta k, and that's important. Theta k, according here to the formula I'm using, it's equal a tan 2 negative bk ak. It means when you find the tangent, you divide negative bk over ak. If you use this formula, a tan 2, you'll be safe. You don't have to do add pi, negative pi, so just you do it like that if you have a new calculator. If not, then you got to look at the which quarter, so you can add pi or negative pi. Anyway, in our example here, a tan 2 negative bk is equal 8 pi k, and our ak is 0. bk is the imaginary part, ak is the real part. So let me just write that. That represents the imaginary part, and that's the real part. What does it mean? Means if you have the unit circle here, that's the imaginary. That's j and minus j. And that's 1 and -1, the real one. So if you have negative bk with negative e, whatever the magnitude, -10, let's say that that's, I mean, you have it here, something like that, and you have it here. Because there is 0, you don't have any point in the real. So what is the angle of this one? You have a vector pointing downward, vertical. So what is the angle? Huh? 200, that's right, 270 degrees or -90, all right? So doing that, I can say now that the angle is fixed. It doesn't matter k. If you change k, you still have, I mean, longer, but still only one direction, right? So that would be -90 degrees. In some cases, you'll find that's different, it's varying with k. Like, for example, let's say that you have bk is equal, I'll make it the same like that, pi over k, and let's say that ak, like pi over 8, for example. So if you have something like that and you don't find the angle, so say theta k is equal a tan 2 bk, and this is pi over 8. So obviously ak is fixed all the time, doesn't change with k, but the other guy is just changing. So if you take k equal 1, you have -8 over pi, and this one is equal 8 over pi. So the vector will be like that, and that will be your angle theta k. In this case, theta 1, because k equal 1. So how you find this one? You divide the 8 over pi over 8 over pi v1. So actually, this is 45 degrees. So theta 1 in this case equal -45 degrees. Yes. Pi over 8. Yes. Oh, that's, I mean, just exhausted person. Yeah. Didn't sleep well. All right. 8 over, that's all right. So if, let me, okay, let me just make sure. Oh, so that's different now. So when you find the tangent here, the vertical is equal 8 over pi divided by, but it's negative, pi over 8. So what you get? -8 over pi divided by pi over 8. Oh no, I meant, I mean, actually, I want to make this 8 over pi, actually, because I want to make it easy. 8 over pi. That's equal to -1, that's -45. Let's take another k. Let's take k now equal to. Because I mean, in our example, it was easy, -90 degrees, and then you're not going to face this situation everywhere. Well, when k is equal to, so what we'll get? Now we will have theta 2 equal to, that's theta k. A tan 2 negative bk, you would be equal to, so it would be -8 over 2 pi. A is constant. Be fixed. That we choose 8 over pi. 8 over pi. So how you get it? So you divide, if you divide, I mean, to find the theta will be equal 10 minus 1, -8 over 2 pi divided by the real part, 8 over pi. 8 cancel with 8, pi cancel with 8 will be 10 minus 1, -4. Then you got to use the calculator to find that. But you can say it's equal to -10 minus 1, 4. You can do that. Why? Because I mean the A is positive. That's why. If A is negative, there's another story. So A tan -4. All right, it's equal to be negative 76. So it was negative 90. Now it's negative 76. And you can put k equal 3, you get another angle, and so on. So I'm saying theta is changing with k in general. But in our case, it's just, it was no real part, 0. So it doesn't matter the amplitude of the vertical, it's still -90, -90. All right. So how can you sketch the line spectrum? Well, first, let me write CK, the expression we found CK here, we found equal 8 over pi k. 8 over pi k. And theta k, it's equal -90. And remember, CK only for odd, for even is equal 0. So you make your table. You make table to do the line spectrum. And that will be very similar to what you're going to do in the lab next week. And you have already your pre-lab, so you don't have. You do that, you say K. Let me add another one. And omega, the frequency, and CK, theta k. And you just put in the table, you see omega naught is equal 1, the value. And then you divide this one according, if you request 7 terms, 9 terms, whatever. Then you divide your table to, that's k equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you continue as much as the ask. When k equals 0, you know, you don't use this formula because you have C naught, you got it, equal A naught, which is equal 2. So it's equal to, okay. Oh, I'm sorry, I did the wrong. 2 is amplitude. What about the frequency? 0. It's DC. There's no angle for the DC. 0. What about 1? You substitute in this one, 8 over pi will be 8 over pi. What the frequency? You are lucky here because omega naught is equal 1. And how you find that omega in general is equal k omega naught. Omega is equal k omega naught. So 1 times 1 is equal 1. And the amplitude is equal 8 over pi. And the angle is -90. 2. The frequency of 2, you multiply 2 by 1 is equal 2. In some cases, if you have omega naught, for example, equal 10 radians per second, you multiply 2 by 10 between. But in our case, it's very simple case. K by accident is equal to omega. What is the amplitude of 0? Because we said this formula only valid for odd number. So the amplitude is equal 0. Go for 3. 3 times 1 is equal 3. The frequency equal 3. The amplitude 8 over pi 3. 8 over pi 3. Of course, you can do it in the calculator and find the value. And the angle will be the same, -90. 4 is equal 0. 5 will be 8 over 5 pi. I'm substituting in the same formula here. Oh, that's the frequency. The frequency equal 5, and that's equal 8 over 5 pi, and the angle is equal -90 degrees. Yes.
So for our K of 2 and our K of 4, why is the omegas 1, 2, and 1, 0?
No, the omega doesn't change. Omega should be 4. Yeah, omega has a value all the time. All right. For 7, that's the last one. Let's do it. 7 times 1 is equal 7. You substitute by NCK by K equal 7. So you have 8 divided by 7K, and the angle is still the same, -90. So now we have relationship between frequency, amplitude of each component or each harmonic, and the angle shift of each. So when you do the plot, that's omega. If you are going to use K, you can do that. You can write K. You have the choice. because k is the index of the harmonic. Like if you write k equal 1, it means you are the fundamental. Right? K equal 3, it means you are the third harmonic. And you understand that to be 3 times the fundamental frequency. Now, let's say omega equals 0, 1, 2, 3, 4, 5, and just to continue, you can as much as you can. At 0 is equal to, so you make a line is equal to 2. That's the 0 component. I got from this here. The fundamental, it's 8 over pi. So let's say that will 8 over pi, you make it a bit like that. 0 at 1. I'm sorry. That's the fundamental. That's at 1. I should do it here. And that's the amplitude is equal 8 over pi. 2 is equal 0. 3 is equal 8 over pi over 3 pi. 4 is equal 0. 5 will be smaller because every time you are dividing by big number, 8 over 5 pi. That's 0, and you continue to scale. This is, I mean, line spectrum. Line or amplitude, let me just write. Amplitude spectrum. To do the line spectrum, you have to have 2 plots. One for the amplitude and one for the graph, the phase. That's also omega or k. You are free to choose. And that's, you write theta k. And this graph will be phase spectrum. Shows you the shift, the phase shift. At 0, nothing. At 1, you know, it's everything negative 90. So you said negative 90 will be at 1, negative 90. 2, nothing, 0. 3, negative 90. 4, 0. That's the phase spectrum. Amplitude spectrum and phase spectrum together, what they are called? Line spectrum. And that's everybody in the end, after they finish Fourier series, they want to look at this diagram. You want to look at this plot. You want to, so when you look at it, then you know the amplitude of each harmonic, which is really important. Yes.
What value on the line spectrum of that
Amplitude spectrum.
What value is at that 0 line?
This one, 2, because that's the value of the average, the DC component. Yeah.
Gotcha.
So that's I mean how they make the, let's say, the evolution of Fourier series. They make it compact after that. Then they got something which is called complex Fourier series. Complex Fourier series. Complex Fourier series. They only use the exponential you guys didn't have quiz last time, and I mean, some people they expressed that they missed the fun last time, so I want to miss twice.
How'd I have those notes? I can't believe it.
It will not help you. There is no hope, you know.